Hi, my name is Brian Henderson. I'm here at TechEd 2013, and I'm here to talk to you about why VNX for Microsoft environments. What I'm talking about is 5 points. First, performance, capacity optimization, protection, management, and virtualization. We think that this is the right package for Microsoft environments. Let me explain each one in a little bit more detail. First of all, performance optimization. What I mean by that is the ability to dynamically sense your workloads and tune the array depending on what's happening in this system. We call these our flash-first strategy. The ability to take a flash drive and use it in a number of ways, as a tier, as a cache, and to be able to automatically sense the workload and pick that up right away. Capacity optimization is the ability to use thin provisioning features and storage pools built in the system. Everything we do is non-disruptive, and you can expand your disks on the fly. So this is really thin, online expansion, the ability to add capacity and not slow down operations. Protection. What we do is offer a continuum of protection options ranging from our backup products such as Avamar, such as Data Domain, and things like RecoverPoint and vPlex, which gets you continuous protection and continuous availability. So this is really, I'll just put RP and vPlex. Finally, we have management integration on the Windows side. So we plug in the System Center. We have Unisphere management. We have Unisphere Remote, which manages multiple Unisphere systems. Unisphere, as well as our ESI, which is actually a nice integration for the Windows environment. It's a very, very nice feature that we give away for free. Virtualization. We have been the leaders in virtualization integration for quite a while. It's really the foundation of our cloud strategy. And we offer VSI plugins to let you plug directly into vCenter and manage our storage arrays from within vCenter. And we also offer a lot of integrations. There's over 80 direct calls into VMware. We also do the same thing with Hyper-V. So whether or not you're using VMware or Hyper-V, we've got you covered. We think we're the right solution as you go towards the cloud within a Microsoft environment. Thank you. We're here at Microsoft TechEd 2013. I'm here with Mike McGee. How are you?
I'm doing well. How you doing?
Good, good. Mike's here to talk to us about fast-track solutions for VNX. You've been talking to people at the booth about it. Can you tell us a little bit more about that?
Sure. So for the past year or so, we've been focusing on the next revision of the fast track program. So this is the fast track version 3. So what it is, it's a reference architecture designed by Microsoft, focusing on the Microsoft stack, if you will. So it's Windows Server 2012, it's System Center 2012 SP1, and it's the entire System Center family and Windows built on top of a specific hardware stack that we define. So we have two solutions that are out there today. We have a small configuration based on VNXE, along with Cisco UCS, and then we also have an enterprise solution that's based on a VNX 5500 that's also tied to UCS. The hardware is interesting. We go into how to configure it fully redundant, but we've been doing that at EMC for a very long time. So a lot of the real interesting things that we get into is the integration points. So how do we tie into System Center? How do we tie into Windows and some of the built-in functionality? So within each one of these reference architectures, if you will, within the private cloud fast track, we define the protocols. So with the enterprise, for example, we have Fiber Channel, we have iSCSI, but we also have SMB 3.0. Within the small, we also have iSCSI and SMB 3.0, which are supported on the VNX today, the file functionality. We talk about the System Center integration, so our integration with the storage management with SMIS, for example. We have integration into Operations Manager, so the SCOM adapter, so you can start bubbling up alerts into System Center from the storage array. We go into and even test some of the more integrated features with the storage array, things like offloaded data transfer, things like thin reclamation, and also the SMB features like multi-channel, like continuous availability, and we hammer at that within the private cloud fast track. We have Microsoft come and they look and confirm the environment. You go through a validation process, and then we document everything, soup to nuts. I think the enterprise documentation is over I think like 600 pages. It's over 100 megabytes because it's a step-by-step, both from Microsoft and Cisco and EMC, on how you build this out, literally soup to nuts from the ground up.
Where can people go to find out more information about that? Is that up on a website somewhere?
Yep. So there's several documents that are out there. There's reference architecture documents, which are a little more high level, that give you an idea of what these, what are the components that we're talking about. And then we actually have deployment guides that are posted that will give you all the information on how to design it from the ground up. And then we have partners. The program that we're using is vSpecs to deliver the hardware. So there's actually vSpecs SKUs associated with these fast tracks as they're defined. But they're also flexible, so while there's a SKU that you would order, I mean, you can choose the number of servers in some cases, the kind of storage that you're talking about, whether you would want to use fast cache or other things that might change the price. But there's flexibility in it to allow you to be able to do that.
All right, sounds great. So if you're interested in more about this, go to our website, emc.com. You can search for vSpecs and fast track solutions, and you'll find your information. Thanks a lot, Mike.
Thanks a lot. Yep.
Bye.
Too much, not enough. Thanks. All right, so hi, Mike McGee with EMC. We're here at TechEd 2013. We're talking about some of our storage integration. I have a demo here where I'm going to talk about our unmap and reclaim capabilities with thin devices on a VNX. This happens to be a VNX 5500 that we have within a qualified private cloud fast track configuration. What I'm going to show is it's really basic, really simple. Is when you do certain things within Windows Server 2012, for example, if you delete a file, if you run a defrag or optimize drive command, or even when you format a file system, by default, Server 2012, if it detects the fact that a thin LUN is being operated against, it will reclaim the space that's being requested within the file system. So what we have here as a part of the demo is a file system that has it's a CSV, has a 500 gigabyte file within that file system, and you can see on the left-hand side we actually have those allocations within the thin pool. So you can see 530 gigabytes worth of space allocated. Part of that is this 500 gigabyte file. So if we delete that file within Server 2012, obviously it's removed from the directory. But with 2008, or even on a storage array that doesn't support this reclaim capability, it would still end up being allocated within the thin pool. But here, because we can actually reclaim that data, it's actually being pulled and reclaimed from the thin pool. So not only do you get the efficiency within the file system and having that data cleared and freed, and I've sped this up a bit just for the sake of the demo, you can see it also gets cleared within the file system. Now you'll notice here at the end, we still have 30 gigabytes allocated. There's actually 100% free space within that NTFS or within that cluster shared volume. So one thing you can do is actually run a manual operation, which is to optimize the drive, and you can do that from PowerShell, and you can also do that from the defrag or optimize drive GUI. Now, because this is a CSV, to do a manual operation like this, to do an optimized drive, you actually either have to put it in redirected mode or into maintenance mode. So what we'll do is we'll just quickly put it into maintenance mode to allow us to run this optimized drive command. If it wasn't a CSV, you wouldn't have to do this. You could do it while it was completely online and being accessed and not within the maintenance mode. So we did that, and now we can go into the tools menu. Again, this is one way. You can also do this with PowerShell. You can choose defragment and optimize. Go ahead and select that drive where we still have that 30 gigabytes remaining, and go ahead and say optimize. You can also run an analyze operation that will give you some idea of the amount the efficiency that can be obtained by actually doing the reclaim operation, not dissimilar to a defragmentation operation that you might be more familiar with. So you can see we kicked off that operation. You can see it's saying trimmed. So it's going through, and it's going to read the allocations that are available and actually say, okay, I'm going to reclaim that space. So it's going and trimming that drive out, and you can see the remaining space within that file system is being reclaimed. So, and again, you can do it when deleting the file on the fly. That can be reclaimed. In some instances, it might not. You can run an optimized drive that can reclaim it. And if you're repurposing a drive and you reformat it, it'll also do a reclaim at that time as well.
All right, we're back at Microsoft Tech Ed 2013. I'm here again with Mike McGee, and he's going to show us a demo now of Operations Manager, the integration with VNX. Is that right?
That's right.
All right, let's get to it.
So what we have here, this happens to be set up and installed in a private cloud fast track environment that we've validated. It's a VNX 5500, and what we have is the EMC Storage Integrator product, the ESI for short. And with that, we have a SCOM management pack, so System Center Operations Manager. We have a management pack that we provide, and what it does is it allows the storage array to have alerts that bubble up into ESI, and then ESI then sends that into SCOM to give you the alerting and the visibility into the environment that you need. The SCOM adapter gives you several layers. It gives you some logical layers and some physical layers in which you can for example, you have logical components such as storage groups, as well as storage pools, and then you have physical components like your power supplies, your physical connections to the SAN, etc. So you get alerting top to bottom through this integration. So why don't we go ahead and start the demo and take a look at some of those things. So you can see here the EMC Storage Integrator plugin goes right into Ops Manager. You have active alerts, and you have your overall topology. So if we take a look at the overall topology, you can see we have our ESI service. You specify which hosts are going to manage and actually export that out. Once that's discovered, you actually find what arrays are shown. And you can see here it's put into different buckets at the higher level between healthy, warning, and critical. So let's dig in and find out, what was that critical alert. So we take a look and we see, we go to active alerts and we see, oh, well, there's a bus alert on bus 1. So if you go ahead and take a look and dig in deeper, we can find out that there's actually a failed drive against that bus. So we have a bus critical alert, and we have a failed drive. The drive is bad. It's not marked as critical because we actually have a hot spare invoked against that drive. So we're not in any danger so far because we have that hot spare, but we know we have a drive that we need to report on. And we've been finding that with this kind of integration that the server admin is now alerting the SAN admin that there's a problem in the environment, maybe even before the SAN admin knows. So what else can we find out based on that event? So we know we have a bad drive. Well, does that impact a storage pool? Well, in fact, it does. So if we go into our storage pool view, again, one of these logical components that we talked about, we can see that we have a warning against one of those storage pools. Well, maybe you saw that first, or maybe that was the first warning you saw. Well, here's our pool, and oh, there's that same bus 1 enclosure underneath that object, which is causing that alert. So if it's a related object to a failed drive, to a failed port, you might have a port failure which might impact a storage group. So we have storage group logical objects. If there's a problem, that'll bubble up, based on the physical problem. So you get to see the effect of affected entities, relationships, and again, you get to drive that information down to your SAN admin if they're not aware of it already. So while we're talking about storage pools, we talked about health status. We also have health status based on states. So for example, free space within a pool, how much is consumed. We can see that these are all healthy. They all have the correct amount of free space based on our thresholds. But you can also dig in and have charts and give reports. There's a chart view that you can see where you can actually find out how much is allocated, how much is free, and set alerts based on what you want to have within those given roles. So real monitoring, soup to nuts, logical, physical, to help you really drive that awareness in the environment. So we're here at TechEd 2013. My name is Mike McGee. We're talking about some of our software and integration with Microsoft technologies. I have a demo here I'd like to show you. It's about offloaded data transfers. A lot of people know about offloaded data transfers, ODX. It's a mechanism that allows for the Windows operating environment, specifically Server 2012, to call down to the storage array and request that the storage array do a copy of a file as opposed to the operating system itself. But one of the cool features that's not talked about as much is the ability to do a write offload. And that's the idea of, hey, I want to write a bunch of patterns, a similar pattern to a file, but I want the array to do that. I don't want to have the host issue those commands. So what we're going to show here as a part of this demo is the offloaded data transfer write offload capability. So what we'll do first is disable ODX, just to give an idea of the kind of performance that you would see when ODX is disabled and when you're doing a bunch of writes to the array for a general process. We're also going to check the space. This happens to be a thin pool, and this happens to be a thin LUN on a VNX 5500. So we see here we're consuming about 47 gigabytes worth of space within that pool. Now what we're going to do is create a fixed virtual hard disk. This is specifically a fixed VHDX. So it's a Server 2012, a fixed VHDX. And we're going to create 10 gigabytes. And if you're familiar with this kind of virtual hard disk format, it zeroes out that file as a part of its creation. The benefit is you're allocating that space. You're going to get known performance. You're going to get known space utilization. But obviously, it takes a little while to create. So this is 10 gigabytes. I sped that up, but it ends up being about 240 megabytes a second, which is, that's not bad. It's a VNX. It's a powerful array. It writes that out pretty fast. So we'll go ahead and check the space within that LUN and the thin pool. And you can see that we've actually allocated that space out. So we were at 47 gigabytes, now we're at 57 gigabytes. So we've written it out, we've allocated it, so we know that's not only allocated within the file system, we know it's actually allocated on the thin LUN as well. So we'll go ahead and enable ODX. So this enables both the copy offload as well as this write offload functionality. And now we'll run the same command, only this time we're going to make it a 100 gigabyte file instead of a 10 gigabyte file. Now after hitting enter here, I did not speed this up as a part of the video, and that's in real time. So 100 gigabyte fixed VHDX file comes out to about 31 gigabytes a second. And what you'll find here, which is unique, is that we actually didn't allocate that space within the pool. As a part of doing the write offload, we know in certain cases we already have zeros within that pool. We're going to report zeros to the server operating environment should they request that data, but we didn't allocate it. And one of the reasons why we didn't allocate it, actually before I go into that, you can see that the actual file system, however, you can see the actual space being taken up. So that file system thinks it has a 100 gigabyte file allocated and a 10 gigabyte file allocated. And that's the end of the demo. But the reason we didn't allocate that data is with Windows Server 2012, not only does it have efficiencies in allocating and copying data, it also has reclamation capabilities. So if I took that 100 gigabyte file, if we allocated all those zeros out, if I presented that to a virtual machine, a Windows Server 2012 virtual machine, and then formatted that LUN, it would reclaim all of that space based on that reclamation capability within the array. So we're trying to be efficient. We don't want to write that data out just to reclaim it again. So we decided that as a part of that default behavior with ODX, we're not going to allocate it within the thin pool. But that's another bit of functionality we can look at in the future too, the unmap and reclaim functionality with Server 2012. But thanks for your time.
Hello, my name is Robert Wagner, and I'm here at TechEd 2013, and I'd like to show you a little bit about Hyper-V continuous availability with vPlex. So, without any further delays, let's go ahead and get started. What we'll do is we'll go ahead and go through the vPlex GUI, and we'll start setting up the Microsoft cluster. We'll go over to the first side of our vPlex, and we'll set up the distributed volumes. Basically, these are RAID 1 mirrors with half of the storage living at one site and half living at the secondary site. You'll see on the right side of the screen, we've got cluster 1 and cluster 2. They've got the same amount of storage on both sides. And you'll see that we've got data, we've got logs, and we have cluster shared volume along with the shared quorum model. So let's go to cluster 1 and look at our storage views. The storage views are where we've actually put the volumes. You'll see we have LUN 0, 1, 2, and 3. It's our quorum, our logs, data, and cluster shared volume. We go to the secondary node at cluster 2, which is N4. You'll see we have the same 4 volumes shared across that cluster. Now what we're going to do is we're going to go ahead and look at the consistency groups. I guess we're not going to look at them. We're going to go ahead and set up performance monitoring across the 4 virtual machines that we have set up. Once we've set that up, we're going to come over to the roles of our cluster manager. We're going to look at our failover instance of SQL 2012 as well as our 4 virtual machines. And we'll go ahead and initiate a live migration with the 4 virtual machines. Apparently not. I messed that up. So the virtual machines all run on the CSV. And then you'll see that the SQL data and the SQL logs each run on their own node. Both of the networks, both public and private, are set to run the live migration. So now we'll actually start that live migration. And once the live migration starts, we're going to go ahead and flip screens real quick. And we're going to go back and make sure that there's actually something going on in those virtual machines. So I'm going to open up a remote desktop section to each one of those virtual machines just to show that iometer's running, and it's got a 70-30 ratio for reads and writes, and it's going across all the VMs. So as it moves, you'll notice that none of those VMs will go offline. They continue to crank I/O. We'll also switch back to the performance monitor screen and show you that the performance maintained throughout the entire live migration process. So it's just about done, and there you go. It's already moved. So we switch back to the screen. You'll see there's no dip in performance. The I/O maintained across the whole board, and we're right at about 45 seconds. And that's the demo. Okay, so this will be a comparison to the Hyper-V continuous availability failover, or live migration. What we're going to do is, in this scenario, is we're going to do a Windows failover cluster instance, and this is SQL 2012. It's running on N2 right now, as you see up here. And as we fail this over, we're going to go ahead and look at the performance. I've started the performance monitor before. You'll see up at the top we've got IOs running on each path. And we're going to go ahead and move it to the other node. This is a 2-node cluster, so we're going to move it to N4. We're on N2 now. As those resources go offline, we'll go back and look at performance, and you'll see that it's now going to flatline. This is the point of the failover where the instance goes offline and gets restarted on the opposing node. You'll see that the services are now coming online on N4. And as those come on, we'll go ahead and wait it out. You'll see the timer's up to about 41 seconds. And we'll go switch back to performance real quick, and you'll see that now we're ramping our IOs back up, and we're continuing the IO on N4 node. And that's the basic difference between a Windows failover cluster and a Hyper-V live migration.
Hey, this is Phil George. I'm here at Microsoft Technology, or Tech Ed 2013 this year down in New Orleans. And here I'm with representing EMC and focused on our backup and recovery products. We're looking at Avamar and Networker and Data Domain and how they're optimized for Microsoft applications. In fact, right here I was just talking to a customer about Microsoft SQL Server 2012. And in this upcoming release, you're going to see some new innovation from the EMC Avamar and Networker teams where we're putting better visibility and control for the database administrator. What we see here is the SQL Server Management Studio. This is the area where the SQL Server DBA likes to spend their time, and now they can set up a lot of the key advanced options for backup and recovery right in SSMS. And one of the key ones we like to talk about is setting that priority, and one of the key priorities is being able to do a preferred passive backup. So if your passive databases are available, it'll do the backup there. If not, it'll find an active one. Your backups always finish, and your recoveries are fast and reliable. Again, Phil George here at TechEd 2013. Take it easy.